Okay, so um, where did we stop last week? We stopped somewhere around, if I remember, it's around here. Yeah, so we finished print and input functions, right? The most basic functions that you will learn in Python. And some basic input, output, and scripting. Indentation. Yeah, we'll get to learn this one on the next section. You don't really need this one right now. Last week, because we were just learning functions as is. We did not have anything that needs indentation, right? Naming variables and function types. Yeah, we already know this one. Kind of start with a number. Yeah, so these are some rules, right, when naming variables. Only letters, numbers, and underscores. No other special characters are allowed in Python. Also, you can start with a number. It is case sensitive, so um, if you have like a variable name of base and then another one, let's say this is equals to 2, and then base here with a lowercase b is 3, and if you print them out like this, start with the first one. If you print them out like this, you'll see that they have different values. Okay. Um, Next is cannot use reserved words like print. Yes. Once a function has been made, right, especially if it's built in like this one, it will turn green, right? So the moment it turns green, it changes color. Um, that's the time that you will know that somewhere in your program or built in Python, there is a function that has a similar name. So you have to avoid that one. Otherwise, it will cause an error. Okay. Um, I have to switch back frequently to Discord to see if there are any chats. Okay. And that's about it. Yeah, underscores. There are a bunch of ways, different ways of creating variable names. So there are naming conventions that we follow. Usually, you adapt the naming convention depending on where you're working at. So if the team has this kind of convention, you have to follow that one. But there's a lot of um, general conventions out there. One of them, what that I like about is um, you put the data type in the beginning, right? So string or num base, so you know it's a num, or even better, you say int base. See, um, you will always remember what data type it currently is or it should be, right? So any conversion, any steps that you need to take will be immediately evident based on the name of the variable. So just like with the input, if you remember, the return type of the input is a string. So automatically, um, if the name of the variable is int base, right? So you know you have to put an extra step there to convert the string into a int data type. All right. So that's one way of naming it. But really, it depends on you as a programmer. Again, you usually adapt the one that your team is using based on where you're working. Another one that's good is the underscore. So you separate the different words using underscore. So maybe like wait, wait, then underscore the unit, kg, something like that. Or you can start with I think this was called the snake case. You start with a small caps letters and then followed by each word is followed by a capital beginning letter. So weight, kg, and then wait, how about let's do something. So weight and then height and then BMI. So something like that. So every beginning letter of the second word onwards is capitalized. Some also want it to have every word capitalized. It really depends on you. So yeah, that's just a few of the naming conventions, right? Which convention you follow, right, depends on you. But the important thing is that you should always have um, descriptive naming. Just from the name itself, you will know what it's used for, what unit it should be, and the data type should be immediately apparent, right? Because you're going to be dealing with a lot of variables, and if you have some like very weird variable names like John, that's a name, right? So what is a John? You're not really sure what it is. Is it a number? Is it a string? So make sure that your naming convention is just descriptive. Um, it's intended. The name is describing what it is intended for. All right. Okay. Let's see. Yeah, we don't end in semicolons anymore. That's one of the things that makes Python easier. In other languages, you will see that every end of their statement. So when I say statement, that is basically just a line. Okay, so every end of their statement, they put a semicolon, right? That's the easiest description I can say for a statement. It's just a line, but basically a statement is one whole line up until to the semicolon. So yeah, in other languages, the program when it's reading when your computer is reading your program, it has to look for that semicolon to know that that is the end of your statement. But in Python, it does not need that. It treats every line like this one as a statement. Even if you go to the second level or third level, Python is smart enough to identify if that is the beginning or end of a statement. Later on, we'll see some examples of this. All right. Um, yeah, tabs and indices. We'll get to that after this. Um, Predefined. Yeah, we can do that next. Comments, right? So I've been using this one for quite a while. If there is a hashtag or a number sign preceding a text like this one and then followed by a space or no space at all, it will immediately be considered a comment, right? So from the name itself, comment, it's used to describe, right? Describe the code in as few words as possible so that it is easily understood, right? Um, Programming is a type of job where not only you will read the code, others will also read your code. So you have to act like you're talking to the other programmers through your code. You're talking through your code, right? So don't expect them to like understand a complex lines of code, bunch of lines of codes, right, or a complex function that you created. Instead, write a comment, what it does, what it takes, what it will produce, and what it's for, right? So be very descriptive, as few words as possible that will just explain everything, and then it will make it easier for them to review your code, right? They have to review your code before plugging it into the master code, right? Um, so that's part of the development cycle when you're trying to make something. But yeah, that's the main purpose of the comment. Other tricks for comments is when the computer is reading your Python code, it essentially skips these lines, right? So others use the comment as a way, as a shortcut for disabling a few lines. So in this case, I disabled this line. Um, so it basically this was never initiated and it will never be read. So this should have an error because it cannot find basically. Oh no, wait. Okay, so since we ran this one earlier, base was already stored somewhere in memory. So even if we disable it here, since it was already in memory, it can still see that it was 3. Okay, but if we change this one to 4, maybe. Okay, let's change this one to 4 for now. All right, and then let's say I'm gonna comment this line out because I wanted to change this one to 3. So if I were to run this, as you can see, wait. Let's see. Yeah. So as you can see, since I commented this one out, it didn't really change the value of base, right, to 3. As you can see, it's still 4. So yeah, it effectively disables a single line. Okay. Okay, so I guess we can just use this exercise later together with our exercises here. I hope you guys also were doing some self-study last week, to further enhance your knowledge. All right, so I think that's it for last week. We can go ahead to this one. All right. So our goal for today would be to finish everything in Python, right? So that you guys can um, do it on your own. Let's see. There you go. Okay, so Python controls structures, functions, and data structures. By the way, if you don't have your Jupyter Notebook, now would be a good time to turn it on. So these are the topics: conditional statements, loops, defining and calling functions, lists, tuples, dictionaries, and sets, objects, methods, and properties, right? So here we will discuss in detail what objects are, okay? All right, so conditional statements and loops. So we're gonna start with conditional statements. So these statements are used to test for particular conditions and have set responses. All right, so this is what makes computers look smart, right? These are the things that we use to make it look smart, because it looks like the computer is making decisions where in fact it's just multiple conditional statements that developers have anticipated that you will have. Based on different responses, it will have different results. Okay, now before we get to that, we need to know what operators are we going to use for conditional statements, right? So you see here we have some conditional tests, right? If there's just an equal sign, that is an assignment operator. So as you see, sample equals 24. If there's two equal signs, basically it's a equality operator. So you're trying to check if the sample is equal to the number 40. See the difference? So this one, 24 is assigned to sample. Here it's being compared. Is sample equal to the number 40, right? The same goes here. This is the operator for not equal. So it starts with a exclamation point followed by an equal sign. So is sample not equal to 40, right? Next is, of course, the things that you know in mathematics already. So we have the greater than, the less than, greater than, equal to, less than or equal to, right? These are the basics that we need to know, right? Other than the equality and inequality, the others, you should be familiar with them already, okay? Now, um, what do these things um, output, right? So this is an operator. That means it's a kind of an operation, right? But also means it can be evaluated into one single value. So for conditional statements, the output that will be generated is a what? There's just two values for this. It's either true or false, and that is the Boolean data type, right? So I think I took note of this before. So the Boolean data type, right? It has only two values, true and false. So true is recognized like this, false is like this. T and F needs to be capital in order for it to be recognized by Python. Okay. Now all those things that you saw earlier, I'm gonna close this group. Okay. All these things will have true or false outputs to them, right? So let's try them out. So if I say sample, right, we'll assign a value of 50 to this. If I were to say sample is greater than 40, right, it will say true. Technically, there should be no output, but this is, since this is the last line, it's just showing you what it's returning or what it's being evaluated to, right? This output has nowhere to be saved. But if you assign this to a variable, let's say, um, mm, let's try something more uh, appropriate. Let's say age, right? And then 18. Is age greater than 18? And where do we save this value, whether it's true or false? Uh, where, let's say, um, let's say this is a variable called age requirement, right? And then equal sign. Okay. Now we are assigning this to the age requirement, right? Whatever the output of this is here, and then we're going to print that one, So it's false. So right now, our code is like um, a bit dynamic, right? Flexible. All we need to do is just change this one. But to make this more flexible, we can uh, change this one to input, but we need an additional step. So if we change this one to input, right, we'll make this even more dynamic, right? We're gonna ask enter your age, right? So 20, for example. But there's an error because this thing returns a string. All right. But as you can see, the error occurs in the second line, this one, right? Not this one. This is where the error occurred because you can't compare a string to a number. So what do? We need to convert, right? Um, if you've done some research, it should be the int operator, int function in Python. All right, so this is a built-in function. All you have to do, so I won't be going to deeply explain each function, right? We're just going to go over the syntax and how to use it, right? By now, you guys should be able to read them on your own and understand it, okay? Besides, there are some examples here, like what I said before. Okay, so it needs what? A value and a base. Base is default of 10. We are using base 10, so we can just leave it as is. So what? This will return the number in string format, right? So I can just put everything inside an int, right? I can put everything inside an int, and this should work, right? I am passing this one as the argument value, okay, because this will be what? This will return a string, a number in string data type, and that is what it needs. Value, right? A number or string that can be converted into an integer number. Yep, that is what is needed by the int. So it will now be converted, it can be compared, and then we can proceed with our program, right? So if we run this code, type 20, okay, it's gonna say true. We run it again, say 50, and it's gonna say that it is false, right? So now our program is dynamic. We don't need to change anything anymore to get different outputs, right? That's just for comparison operators, okay? So the same thing goes with the other operators. I'm sure you guys can think of other examples using these things, all right? Let's see what else. So we have the int. Yeah, you might be wondering how this one works. Python or any programming language really, they always operate inside out, right? They deal with the operations, evaluations that are inside of the nest, right? Or inside of the parentheses, right? Whoever is the one in the deepest part will be evaluated or processed first. So in this case, when Python or when your computer encounters this line of code in Python, it processes this one first before the outermost function, okay? Inside out. No matter how complex your statement is, it will always try to evaluate the innermost state expressions or evaluations or functions. Um, Even if there are multiple, right, same level. If I have two, like for example, I have two of them like this, um, like that. Uh, they have to be evaluated, right, first before the outside can be evaluated, and then finally the last part is the addition of both, right? So that's one thing that you have to consider when you're programming. All right, next is, so we can, yeah, you can actively assign Boolean values, right? So one example is using active and inactive to true and false. It really depends on the naming conventions, on what you're making. If you want the active to be true or inactive to be false, this is usually what is being done, right? Um, because just setting true to true or false might get confusing sometimes because it's a different naming convention. Whereas you were to equate it to the word active or the word inactive, right? If it syncs with all the other parts of your program, that is better in the long run. Okay? Questions so far? Okay, none. All right. Next is the if statement. Okay, so this is our conditional statement. You can see here, we have an x, right, declared and assigned a value of 5. And the next line is if, this is how you use the if statement, if followed by the condition. That is how you use the if statement. You start with an if followed by the condition. Take note, the condition doesn't have to look like this. It can just be a variable, and then that variable can be somewhere else where there is a comparison. As long as that condition or variable evaluates or has the value of true or false. All right, that's the most important thing, because if you analyze this one, remember this is what, an expression, and it will be evaluated to true or false. So take note, see x is equals to 5, so x less than or equal to 18, that is true, right? So it's gonna read out like if true, then print underage. So this statement, right, it will print underage because this is true. Okay. The next one is the if else statement. Now the else here will only trigger if the first statement is false. Okay, so in this case, x is equals to 5. It's still true. It will still print underage. But in the cases where it's not true, then it will skip this entirely and go directly to the next one. This is how programs make decisions, right? They take into different variables or um, different parts of your data and see if um, what it will decide from that. Okay. Now, in cases where you have multiple options, we have the elif, right? Or it's just short for else if. Okay. This is just for situations where you have um, multiple ifs. So if x is less than or equal to 18, you print this one. If it's equal to 5, you print this one. If nothing else, if nothing matches those two, then you print this one. Okay, so yeah, let's have a few examples here. So yes, you can, let's see. If, no, wait. Let's start with a declaration. Let's say, let's go back to age. 18. Okay. If age is less than 18. Oh, by the way, I forgot the semicolon. The if, the else, and the elif always has to end with a colon, not a semicolon, a colon. All right. And the next part is, I'm sure you guys have noticed, there is a space. Okay, so we call this a nest. So a nest or a second level, right? It denotes hierarchy. Now, you notice that when I press enter, Python automatically detects the if statement and automatically also adds the indentation, right? That is needed. Okay, now you can manually add it if you want, right? Just don't use spacebar. Okay, so a single tab key is not the same as 2, 3, 4, 4, 1, 2, 3. Okay, a single tab key is not the same as 3 spaces, although they should be technically aligned. Okay, not yet. Okay, that one. So they should be technically aligned, but Python will recognize that um, as an error, or more like it's very prone to mistakes because you're gonna have to keep on counting the space bars, right? 1, 2, 3, 4, 1, 2, 3, 4. Whereas the tab key is a lot easier because you just do it like that directly. Also, Python is smart enough to know that you are working on um, statements like these ones, conditional statements. So it will automatically add um, an indentation for you. Okay, so what does that mean? That means that the code that follows after these, okay, the code that follows, right, after this one, if indented, means that they belong to the second level of this code. All right, what does that mean? That means this code, if anything can be applied to it, is only applied before the one before it. Okay, so that's what nesting means. Um, okay, so let's say, what do we want to do? We want to print something. Um, you are underage. Is that the correct spelling? Um, else, right? As you can see, it's adding automatically the second level. So this one, this print and the print here are in the same level of nesting, right? So here we can say that you can drive your car. Okay, we can use this one as int and then input, right? Enter age, something like that. Make it more dynamic, and that's good. Okay, so again, the important thing here is that it can be evaluated to either true or false. It doesn't matter how complex your expression here is. It can also only be a variable as long as that variable has the evaluated value of true or false. Okay, so that's something that you need to remember. Now, if I were to run this code, enter age, I forgot the quotes. Never closed. Yeah. All right. Enter age. I say 20. All right. You can drive your car. I say 15. You are underage. What if I were to say 18? You can drive your car. So when you think about it, it's correct, but also not correct, right? Because our condition here is less than, where in fact it should have been what? Less than or equal to 18. Or we could also do it another way, right? We could have this one an elif, change this one into an elif, and then have another else condition here, else condition, and then we can print this one that uh, you are exactly 18, right? Because if it's, yeah, if it's 17, invalid syntax. Elif, what was the syntax? Elif. Am I missing something? Wrong syntax. Do you guys see something that I'm missing? Let's see. Just to make sure, I'm gonna try and see the syntax here. Elif. Yeah, I'm using the correct word, Elif. But Elif. Oh yeah, I read. Sorry, I forgot the condition. Elif age greater than 18. Something so simple. Alright, so let's see. 20. You can drive your car. 15. You're underage. And then 18. You are exactly 18. One thing to take note of, right? Even though it's creating decisions for you, you still also have to take note of where your output should be. Okay, let's take note, for example, this one. You are exactly 18. Um, let's see. You can't just swap them out anywhere because it might have a different meaning. Let's think of an example here. For example, let's go to grades. Grades. This is one that I always remember as an example. Input, enter grade. Okay. Oh, God. So, grade. Let's see. Let's just focus on 2 or 3. If grade is greater than 90, what will that be? So that was wrong, by the way. See, I indented this one, but it's not really a nest since this is just um, a variable, right? You can't really declare something to be below the variable because it is just a declaration of the variable. So you can't really do that. So this will produce an error. See, unexpected indentation. So you can't do that. So print. Let's have this score of A, right? Elif grade of 80. Print B. Elif grade is greater than 70. C. Right. Okay, let's just focus on that one. Let's say I will input 90. 90. Right? No, wait, 95. Okay. What what's happening. Grades. I forgot the S.
Batched narrator updates window. Scan. Narrator exiting narrator.
Where was I? Oh yeah, enter grade. So say 95. Okay, so it's gonna enter the grade of 95. By the way, you don't have to put an else if you don't need the else, right? The if and the elif alone can work by themselves. Okay, you usually put the else as a sort of catch-all. If um, like if there were any other responses, you can use the else as something like um, input not recognized, please contact admin or something like that, right? um, what I'm trying to say here is that you need to take note of the correct sequence of your conditions, because if this was like this, right? If we start with 70 and then this is C, and then you end up with the grades 90 here. Oh, I can just type 50. And then this is A, right? You will have an entirely different result for the same grade. So if I were to enter here 95, it will enter C. Okay, even though the correct answer should have been A, right? Um, so yeah, although this is an extreme example, right? You could have used a different operator. What I'm trying to explain here is that the positioning of your conditions also matter, as well as your operations that you're using in order to get the correct result that you want. Otherwise, in this case, it's wrong, right? But it's not a logical error. Python is not returning an error because this is allowed, right? So this is what a bug is. This is what a bug looks like. It is an error that has passed through the checks, and you will only be able to realize it um, if you take a closer look, right? So you have to be careful of this one. Okay, so I hope everything is clear, right? Let me ask you guys first for the if statement and the conditions. Do you have any questions? Any parts that were kind of confusing? Or is everything good for us to proceed to the next one? Let me know. Alright, is everything good? No questions? Alright, so let's try at least one activity that I want you guys to do. Um, you know, just to see if you guys understood. Let's create a simple. Let's see, what would be a good way? Mm, let's see. All right. Here is your first activity. I want you guys to create a conditional statement um, for the different speed limits of a vehicle. Okay, so suppose that if it's greater than 100 kmph, that would be what? This will result into a ticket, right? If it was greater than 80 kmph, this would be a warning. And then if it's just 60 and above, that will just be uh, no warning. Uh, the traffic enforcer will just let you pass through. Okay, so just a very simple exercise. Um, yeah, you guys can start now. Maybe you can do this in 5 minutes, I think, and then we'll check your work. Okay. All right. Sounds good. Let me know if you're done, by the way. Okay, it's been 5 minutes. Does anyone have an answer? Anna, Rika, Vivian, Ryan? Who wants to volunteer? Just a very simple exercise to keep our minds alert.
Hello. Hello po. Sorry.
Yes, yes, Anna.
Ano sir, hindi ko siya hindi ko pa po siya tapos, pero nagkaka-error po ako. Meron po kasi akong gustong ma-achieve, pero hindi naka-elif, may else din po sana kaso hindi ko siya magawa.
Mm,
I-she-share ko po ba yung screen ko?
yes, yes.
Or wait lang po. Pero hindi 'to tama. Ayan sir. Gusto ko kasi sana pong i-ano, yung below 80 sana, maging no
Mm,
warning na siya. Hindi siya kunyari sir tatanggalin ko 'to, like, 81 ay sorry. Kaso wait lang, right 'pag 81 po nasa warning na po siya, 'pag 100 onwards naman po nasa ticket, tama po ba or dapat
yes,
equal lang?
yes. So,
Okey,
it should be greater than or equal to.
okey po. Ayan sir, tapos kapag maglalagay po ako ng like 79 ayun parang okey na yata, tama po ba?
Yes.
Sorry nalilito po ako.
Uh, all right. So that's good. Yeah. So you can also use less than or equal to if you want. You're just gonna have to modify the sequence from top to bottom so that um, it will first trigger the no warning before going to the bigger numbers. That way, um, it will work pa siya if you want to use the less than or equal to operator.
Okey po.
Yes. Okay. How about the others? Did you also arrive in a similar solution?
Yes po.
Alright.
Yung una lang po nag-error ako, sorry yung nakalimutan ko po, talaga yung colon. Para saan po ulit yung colon?
The colon is for
Ah,
the ending statements for if, elif, and else. So as you can see here in my share screen, it's at the end of if, at the end of elif, and at the end of else. Else here. So the colon
okay.
is tells the computer that that is the end of your um, that specific statement for the if conditional. So yeah.
Okay. Parang, kapag true yung condition, parang next, ito
So
yung gagawin na instruction, parang gano'n
yes,
po.
yes.
Okay, okay gets. Kaya parang nag-error po ako. Okay na po.
Okay. Also,
Okay.
please take note, guys. This is a very simple example, okay? But no matter how complex the codes that you will see, it will always go back to this one. You can have as many lines of code as you want. You can even have as many if statements as you want inside of each let's say this, each level or nest. So you can put something like this, and then if that is true, you can have something else again like that. Okay, so let's say for example this one. Let's say the grade is 70. Okay, no, wait. If the grade is 70, okay, I will say that that's good. But if it's still greater than 70, let's say it's greater than 80, instead of printing a C, we'll say that that's better. And then if it's still greater than 90, that will be best. But this is a different output, okay, because it keeps on uh, uh, having follow-up conditions, right? So it will do something more other than printing. Okay, so it will ask more questions. So in that case, the question is the grade greater than 80? Is the grade greater than 90? Right? So the output will look something like this. If you were to do it like this, 5. Okay, so it will trigger every print statement. Okay, because it's greater than 95. So this is true, this is true, this is true. Okay, so you can have as many if statements as you want. You can just imagine multiple questions like, um, let's see, uh, let's say you are, what example did I use before? I think it was an airport example. You're at the airport, right? And they're gonna ask you multiple questions. Do you have an ID? Okay, you have an ID. Okay, that's good. Do you have a ticket? Okay, that's good. Do you did you check your luggage? Right, those kinds of questions in real life. Okay, you're gonna be transforming those kinds of questions into code. Okay, and that this is how it's gonna look like, right? If there are follow up questions, if something is true. Okay, again, it's not really limited to this one, but this is how levels or nesting works, right? It kind of um, tells the computer on what to do next, right? Um, the if statements is like telling you where to go, whether it's true or false. Okay, so um, it takes some time to get used to this, especially the nesting. Um, right now, our examples are very simple, but it can get complicated really, really quickly. One trick that I like to trace is that when the code gets too long, I usually just um, take note of the indents, right, and follow where it begins and try to trace on what are the conditions needed to trigger that one. Or I can just play around with the inputs and see um, what will come out of it and try to understand how the code works from that. That's one way of doing it if you're reading other people's code. Okay, so it seems that everything's good. How about the others? Let's see. So I think that was Rick and Anna. How about Ryan and Vivian? Is everything clear to you guys before proceeding to loops? All right, so I guess I'll get back to them again later on. Oh, I have no mic. Yes, for the okay. All right, so it's just a chat. There should be a notification for this. I can't really hear anything if there's a chat. Anyway, I'll take note of that next time. Okay, so we go now to loops. All right. So from the name itself, loops. This is what you do to repeat blocks of code, right? It doesn't matter what kind of loop. The purpose is to repeat a block of code. We have two loops that are used a lot. They also have the same names in other languages, so it should look the same, and it should also work the same. Okay, let's start with the while loop, one of the simplest ones. Okay, so it repeats a blocks of code as long as a certain condition is true. So take note of this one, certain condition is true. This is the way that the syntax works. You start with the while, followed by the condition, and then the colon. Fairly similar to if, right? It has the same structure. Let's start with that. Okay. This example here, x is assigned the value of 1, right? So while x is less than 10, in this case that's 1, it will print out the value of 1, and then it will add 1 back to the variable x. So this is kind of like a shortcut. So x plus equal to, this is exactly the same, to x is equals to 1, 1, x plus 1. That is exactly the same as that. If you guys are wondering why the need for that ever came to be, um, it's the reason is probably because in the older systems, this had more like advantage in terms of speed. Okay, so let's not get into the details, but the main point is that this is faster compared to this one. Okay, if you were to measure the speed of how the code is being processed, this is faster compared to this one, hence the need for that. And developers didn't really see the need to remove it from future versions, so they just place it there, okay, so that older versions can still work in newer versions. So they did not see a need to actually remove it. Also, it makes the code a lot neater to look at, right, and easier to understand um, when you get used to it. I mean, okay. So what will this look like, right? So Python essentially is stuck in this loop, right? It will be stuck in this loop until what? Until the condition becomes false, right? Because this is what happens. Um, the computer will read this line. It sees it as true. Goes to this line, prints the number 1, goes to this line, adds 1 to x. So x is now 2. After this, since this is a loop and these lines of code are indented, so they belong to a level below the while loop. So that means after this, it will go back up. Okay, now when it goes back up, it will check again this condition, but now the value of x is 2. Okay, so it will keep on repeating that loop until the value of x is equal to 10. It will stop at 10 because now it's equal. That means this will become false. The condition will become false, and it will not print out the number 10 anymore. It will only stop at 9. So if we were to print that out here, say x is equals to 1 while x is less than 10, print x, and then x plus equals 1, run the code, and as you can see, it will only print out up to 9. If you want the 10 to be included, you have to put the what? Less than or equal to 10, and then the number 10 will be included as well in the output. Okay, so you have to be careful again with your operators that you are using. All right, now you might be wondering, what is this good for, right? Let's say, for example, let's think of something practical. Uh, Pin inputs, right? Let's say you have pin inputs. You're making the code for inputting pin on the ATM machine. And then there's a limit of 3. After that, uh, it will not give you back the ATM, right? Okay, so let's start at 1, your first attempt. What will it do? It will ask you to um, say, let's just simplify this one. There's code here, code for accepting uh, ATM transaction. Let's just make it simpler. Okay, so there's a code for accepting ATM transaction. Um, what will we do here? So if it's true and if it's false, right? We need to ask that question. If the ATM transaction is true, if the ATM transaction is true, all right. If true, so this is usually how I program. If I don't know yet what conditions or expressions, I just write the actual value that I want, like this one, true, to help me, think better. But it's really up to you guys how you do it. So if true, what will happen to the ATM? It will just dispense money, right? Dispense money. Else, what will it do? This is what it will do. It will add 1 to the counter. Let's make this one. Wait. Okay. No. Okay, it's not working. Never mind. I thought the shortcut will work here. Okay. It was supposed to highlight all the variables of X and then change it all at the same time into a different variable name. Okay, so I'm gonna change it to counter to actually make sense, right? Where this is an ATM transaction. So if true, print dispense money. How do we know that it's done? So if it dispenses money, right, it should exit out of the loop, right? It should not repeat because it's a successful transaction, right? So let's put a print statement here that says, thank you, just so that we will know that it is outside of the loop, right? So this is inside of the loop, this is outside of the loop. See, because how do we know it's outside? Because of the level of indentation. See, now I know that I'm back outside of this level, this specific nest here. Okay, level nest. Those words are used interchangeably. If you try to look for it on the internet. Okay, so dispense money. What else will happen if we want this one to exit out of the loop? What do? We have to make this condition false. How do we make that condition false? Well, we can just change the value of counter directly. We can just say counter is equals to 5. And that will immediately make this false and then exit out of the loop. But yeah, if it's false, then it will keep on adding 1. Also, it will also inform the user that it's either wrong pin, wrong pin, or wrong pin. Wrong pin. Let's just use wrong pin. All right. So, wrong pin. Okay, that's it. Um, what else? So now we need a variable for this one, right? Let's say uh, pin attempt. Yeah. So if pin attempt is equals to true, right? Mhm. Let's see. How can we make this dynamic? Like we're actually entering a pin. Ah, okay, I know. So, true and false, right, also has an equivalent in terms of number. You can say that the number one is true and the number zero is false. So we can use numbers instead of true and false here. And since we're asking for numbers, we can do this one directly. Int input, and then let's just say enter pin. Sorry. Okay, and then this is the pin attempt. All right, so should only enter only 0 or 1, just for this example, right? So that we can see how the counter works. So if I were to run this code, I think this will work. Okay, so let's try and see if it works if the pin that I entered is correct. So it's a 1. It should dispense my money and say thank you afterwards. Alright, so it works. But if I input it wrong, okay, 0, that's 1, wrong pin. Automatically, it's asking me again for another pin. Let's say I do this 3 times, make a mistake 3 times. What will happen? Wait. Wrong pin, thank you. So there's something missing, right? It should surrender. You should surrender your ATM. That's what happens, right? Maybe we can change this one. We can change this one to elif is equal to 0. We can do that, or we can just, let's see, equal to 0, equal to 1. I think there's another way we can do this, but yeah, this can also still work. But I think there's a better way to do it other than this. But yeah, let's make it work first. So if 1, right, if 0 is this one, next is, okay, the limit should be 3, else where should we put the counter? Wait, I think there's no need for this. Wrong pin. I think there should just be another check here, another if counter is, right, equal to 3, it will print out what does it usually say when the ATM machine takes your card? What does it usually say? Let's say uh, card
Count lock.
account lock. Yeah, I think we can do that. Account lock. Please proceed to nearest bank. Yeah, I think that's good. Thank you for that. Yeah, I think this can work now. So if I do that again, 0, 0, 0, 2, 3. I need to start at 0. Okay. Counter is not 1. Counter should start at 0 because I need to do it 3 times. Okay. 1, 2, 3. Input, enter pin. What did I input? Oh, okay. Um, 0, 0, 0. Account lock. Please proceed to nearest bank. So you should not be able to enter a pin. Okay. So after that, yeah, there are instructions, reserved instructions, especially for loops. So one of them, there's two of them. One is continue. The other one is break. Okay. So at this point, we want the loop to stop and then exit out, right? So we still want it to say thank you, but we want it to exit out of the loop. So you can put a break here, like that one. So after this, it will break. So it will not ask anymore for the pin. It will not go back at the top. Also, this one, right? Instead of changing the value of counter to 5, we can also put a break here. This can also still work. Okay. Pending input. Okay. How do I stop this? Stop. Right. Okay. So if I were to run this again, it is 1. Dispense money. Thank you, Steve. It still works even though we did not change this one because of the break instruction. Okay. If we use 3 zeros, okay, it should, yes, account lock and then thank you, and it should exit out of the loop and say thank you. So the program has stopped. So now this is a complete working theoretical uh, check for pin inputs on an ATM machine. Most likely, yeah, it is in a more complex form in the actual code, but the thought process should be the same. Uh, So yeah, break. What about continue? The continue is just fairly simple. It will just skip the current iteration. So iteration or the current loop, right? So remember, one run, okay, one attempt of this block of code, that's one loop, or we call that one iteration. If it's repeated twice, right, that's the second iteration, and so on and so forth. Third iteration, fourth iteration. How many times the code is repeated, right? That's how many times the iteration is. You'll see that word a lot when you are looking for solutions online, right? They'll use that word, and yeah, that's also one thing that you need to consider. The lingo that they are using in programming. You need to be familiar with each one because that's what they used to talk about in forums and solutions. So, of course, yeah, if you can't understand it, you'll have a hard time applying their solutions to your problem, right? So, the continue is just basically skips the whole thing, right? So, we have an example of a break here, an example of a while loop, how it works in the conditions. Um, Yeah, one thing that you should take note of is that when creating loops, try to avoid creating an infinite loop, right? So let's start with the infinite loop, or oh no, wait, let's start with the continued because it's easier. So x is equals to 1, right? While x is less than 10, okay, print x plus equals 1. Okay, now if we put a condition somewhere here, let's see, if, no wait, let's put this inside of condition. If x is equal to 5, right, this will continue. So what will happen to this is that the moment that x is equals to 5, it will stop at this line and disregard all the lines that follow afterwards in that current iteration. So in this case, 1 in the fourth iteration. So if you print this one out, okay, 1, 2, 3, 4, it will continue, but what's happening? 1, 2, 3, 4. If x is equals to 5. Alright, so this is what I meant earlier by an infinite loop. You were expecting that it will reach to 10, right? But I created actually an infinite loop. Because, why is it infinite? Because it will never reach this line of code. This line of code is what adds 1 to x, right? But since x has become 5, it will always trigger this one. It will always trigger this line. So it will never go to this and this line. It will never add 1 back to x. How do I know that it's running in an infinite loop? Because this one is not yet done. You can see that the kernel status is busy. The elapsed time is 60 seconds. So it's not yet done processing. It's not yet done because it's infinite, right? So try to avoid this one, especially in modern systems, because like if you're using something like Amazon products, um, or cloud products, they monitor how many lines of codes are processed, right? And each line of code, or depending on what plan you're using, uh, is equivalent to a certain amount of money, right? Now, imagine running these lines of codes that does nothing, and then it runs infinitely. It will not stop. They will keep you charging for that since it keeps on running, and then it will amount to a very large sum. This has happened before. It has happened quite a lot. Sometimes the infinite loop is not really apparent in the beginning that you have actually created one. Um, yeah, just try to check that there is a way to exit out of the loop always when you're doing this, right? So how do we fix this code? Um, how do we fix this code? I want it to skip printing the value of 5 and then uh, continue with the next number. So I want it to print 1, 2, 3, 4, and then 6, 7, 8, 9, right? So how do we fix this one? Let's see. x plus equals to 1 is at the bottom here. So we need to print it before this one, right? Now where do we put this condition that it will just continue, that it will not print the x? Let's see, where do we put that? If we put this one here at the bottom, will it work? No, it won't, because the 5 is already printed out. So even though it will keep on adding 1, the 5 is printed out. What we want to do is to skip the print of 5, right? So if x is equals to 5, continue. So what do you guys think? What could be the solution for this one? How do I fix this code so that the output should be 1, 2, 3, 4, 6, 7, 8, 9? Without printing the value 5. Vivian, how about you? Are you here? Do you have a solution for this problem or an idea? Okay, I see you're typing. Okay. Uh, all right. I think let's see. How about Anna and Rika? Do you guys have an idea? Or are you guys still working on it in your notebooks on how to do this? No idea. Okay, that's all right. This is just an activity. How about Rika or Ryan? You can just type your idea if you have one. All right. All right. So let me save you guys the trouble. Okay. So where's this okay, so the problem that we had before was that we created an infinite loop because it never reached this part of our code, right? So that means we can just add this code in this condition. Let's try this one out. Right? Besides, this will only be triggered if x is equals to 5. After adding 1 to it, this will never be triggered again. And it will skip the printing of 5. And after that, it will just continue as is. Right? If I were to run this, there we go. So 1, 2, 3, 4, 6, 7, 8, 9. Right? So all you have to do is actually think of it step by step. What's happening on each line, right? Um, at first, this might be difficult. It can help if you write it out on a paper, or just realize that the computer is reading our code line by line. If you know exactly what's happening line by line, and you keep a mental note of what the current values of the variables are, right? Um, what's currently happening, right? You can solve uh, problems like this one. Okay. I'm sure there might be an easier way or a more elegant way of trying to do the same thing. Uh, I'm sure there are other programmers out there that can do better than what I did here. But the point is that whenever I try to make a program or code, I always try to make it work first, right? And then you tailor it, tailor it afterwards, right? That's what I do. That's kind of like my motto. So I have to make it first, work first, no matter how ugly the code is, no matter how long it is. It doesn't have to be 100% efficient. If you can make it efficient in certain parts, that's good. But it has to work first, right? So, um, as a web developer before, I've seen sites where it's super efficient, it's super clean, but the site doesn't gain income, right? The site doesn't gain income. It doesn't, it did not produce the necessary uh, pool to clients, right? Whereas we have some kind of website like Reddit, for example, it's not really, you know, um, in terms of like code, from what I've heard, it's not really that straightforward, especially the older versions. Lots of um inefficient code, lots of redundant codes that should have been removed, right? But you know, a lot of people visit that site, right? Because a lot of people will use it. Okay, so whenever you're creating a product, right, especially a product that's visual, it the one thing that you should remember is that content is king. So that's the kind of like thing that you should always remember. This doesn't really apply for data science at the moment because we're dealing with, we should explain properly what we have found out through research, what we have discovered, right? The trends that we see, where it's going, what will it produce, right? The algorithms that we used, what did we compare it to? Did we compare it with our rival companies like that? So this doesn't really apply to data science, but this one really applies, right? So you might be thinking your code has to be perfect. No, it just has to work. Okay, after that you can tailor it, you can make it more beautiful, more efficient, line by line, right? So tailor, because that's what they do, right? At the beginning, you're stuck with like the dummy, like a suit. You wear a suit, and then it has a lot of patches on it, and then some some guides, and then they fit you through it, and then afterwards when it's done making it, it actually fits you perfect. So that's what I'm trying to say. Okay. Next is we'll go to the for loop. Um, yeah, after the for loop, we'll have a break, and then the others are not really that difficult because these are just data structures. Yeah, hopefully we can reach the exercises so that your understanding will be solidified. Okay. All right. So the for loop, another kind of loop. Why do we need two kinds of loops? Because the first one has a different kind of control to the second one, the for loops. Okay. Um, the reason is because we can control how many times it repeats, right? Sir, in your example, we did control how many times it repeats, right? Yes, but the main power of the while loop is that you can make it work while something is true. All right, so let me make that clear. If I were to say x is equals to true, for example, right? While x, right, because x is equals to true. Okay, if I were to say like I'm gonna ask for an input, I'm gonna say the to y input. Um, enter 0, 0 or 1. Sorry, we'll use numbers here for true and false. All right. While true, right? Um, we'll print. No, not print. Let's add a counter here. Counter equals to 1. Print counter. Uh, counter plus equals to 1. All right. Input string number. This is number. This should be an int. Okay. No. We'll assign this one back to x, not to y, because it's checking for x. All right. Okay. And then let's have some kind of confirmation here out of the loop. All right. So it should repeat infinitely, but you are in control of when it should stop, right? So I'm gonna say 1, 1, 1, 1. So you kind of get the idea. I can repeat it infinitely if I want, right? And I can also end it if I put 0 like this. Okay, this is the real power of the while loop, right? You have a way to create an infinite loop, but you are still in control, or the user is still in control while not like going to the next line, because it's like it's gonna be processing still, but it's not the same as an infinite loop where you have no control. Now the for loop, right, is especially designed for um, like a repeat for a certain number of times. Although you can do that with a while loop, this is more reserved for a for loop. Now the for loop has this kind of example uh, syntax, and it starts with a for, and then um, a placeholder. You can put any. You can just treat this as a variable, a temporary variable, and then in, and then uh, how do I say this? An object, an iterable object. So that's another thing that we don't know yet. iterable object. Let's just put that here for now. All right. Now the for loop works like this. It's gonna iterate over the object. Okay, so remember what when I said iteration is the repetition of the different blocks of code, right? The current iteration, the fourth iteration. Um, it has a similar function here, but when you say iterate here, right? Um, it's basically the same, but you're taking into account the output, right? It's getting the value inside of those objects. Now, at this point, we don't really understand what's happening because we don't know what range is. Now, the range function here, if you search for it, okay, the range function returns a sequence of numbers starting from 0 by default, increments by 1, and stops before a specified number. So basically, start, stop, step, right? Um, optional, required. That means if you have one number, that is your stop number. The stop number is not included. That's just the way they decided. So if you see something like range 3 and 6 like this, so they assign it to x, right? In this example, for n in x. So what does this mean? This will return a sequence of numbers. So you can just treat this exactly like it's the numbers 3, 4, 5, right? It gives you the numbers 3, 4, 5. And in fact, if you print this one, it will give you 3, 4, 5. Let's go back to this example, to the one that we had. So range 1 and 10. So what was the syntax? Range, start, stop, start, step, stop, start, stop, and then step. Okay, so we have the start and the stop. So start at number 1, stop at number 10, and do not include the number 10. Alright, so that means the placeholder I variable here will take one number at a time, and it will start at 1. Okay, so when Python reaches this line of code, range will say, hey, here's the first number, number 1. It throws it to the placeholder I. Okay, now you can do whatever you want with I, right? Or you can't. It's just there. You don't have to use it, right? Because in this case, we're using the value of x, and we're printing x and increasing the value of x, right? But I is still here. You can use that variable if you want. Okay. Now range. After this code, after this current iteration, it will go back here, the code at the for line, and then it will encounter the range function again. Now the range will say, um, okay, this is the second iteration. Here is my second number, 2, and I will throw you this number, to letter I. All right. Now this is now the second iteration, and it repeats everything. Okay. Now, when will it stop? It will stop when it's in the 10th iteration, because this is the stop syntax, stop argument that we gave. So it will stop at 10. It will not print anymore, and that's it. That's the end of the code. So if we try to put that here, x is equals to 1, right? For I in range 1, 10, and then print x, and then x plus equals to 1. This is what will result. 134 up to 9, right? Now, using the same code, but we're gonna be using I, we want to see what is I, right? What is inside the value I, the variable I, okay? Now, you can see that it has the same values, but remember, these values come from here, whatever the object is in here, but it must be an iterable object, okay? This is one of those special functions that can give out an iterable object, okay? Are there other iterable objects? Yes, we will come to discuss them later on. One of them really is already something that you know, and that is a string, okay? A string is considered an iterable object, all right? In fact, whenever you're looking at documentations, right, especially on other texts, whenever you see this description, whenever it says this is an iterable object, automatically you can put it here. You can put it here, and then you can loop over it to see what's inside. All right, that's one trick that I can give you. Um, okay, so we have I, right? Does I exist outside of the for loop? No, I only exist inside of the for loop. So if I were to check what is I um, here, wait, sorry, uh, outside and then I. Okay. Oh wait, why is it saved? I did I declare I somewhere? Mm. Okay, so hang on. It saves it. Okay. I'll get back to you on this, but it seems that the variable here is actually in the same level as the for loop and the print. So this declaration here is exactly the same as you declaring it outside here and then changing the value later on. So I guess that's how the I did not notice this one before. Usually I treat the variables inside the for loop as um, expendable, something that I will not use later on, because when you think about it, that variable will only be useful inside the loop. So I never put some like meaning to those variables inside there because it's just gonna work there, right? It would not make sense if you were to use that variable outside of the loop, and it will be more confusing and error prone. So I don't really advise doing that. For now, although it works, just treat it as um, it only works inside the for loop. All right, so I have I here. Um, we printed it out. If you guys want to see the step, let's say it starts at 1, steps of 2, that is what will come out. So 1, 3, 5, 7, and 9. Okay, so the main point here is that the for loop stops. Uh, let's say I want the loop to repeat 10 times. So you can just use the range function and put 10, and then um, it will it will stop at 10, or in this case 9. Okay, it will stop at 9 because our stop is 10. If you were to print x and I side by side, this is what it looks like. So this is the x, this is the I. So as you can see, I stops at 9. Okay, but x here stops at 10. Okay. Yeah. So for for certain applications where you want to say like repeat it 5 times, repeat it. My car. My car did it. Okay, apologies for that one. Let's see. Where was I? Right. This one. So in certain problems where you need to repeat just the loop, like I want this one to repeat 3 times, 4 times, the for loop is the ideal one. Okay. Can I do something with the I? Yes, you can do something with the I. In fact, you can use this one like this. So I plus I, the current I. So you can do something like that as well. You can make use of what is in the current, what is inside the iterable object. Okay. Now earlier I said the string is an iterable object. So what does that mean? That means if I say something like this, and then for loop I in name, I would print I. What would this come up? It will print out each of my uh, each of the letters of the string. All right. So strings are considered iterable objects. Only strings. Okay. Numbers are not. Uh, there's two more: lists and data structure and dictionaries. But you have to remember this one. Okay. Other developers can make their own data types. Right? They can make their own data types. Right? So that means you also have to take note of what it can do, if it is iterable or not, right? So you're not just stuck with the basic data structures that we know. You also have to take note or take into account the data structures that other developers make, if they are iterable or not. Okay? But a string is always an iterable object. So you can do this, right? Or if you have like, uh, there are some uh, ways of passing data. Like for example, you say like the birthday is at August. What day is it today? 22, 2026, and then underscore, and then the first name, and then underscore the last name, right? Something like that. So you are almost sure that the first two, four, six, eight, the first 8 characters are um, birth date, right? So let's say this one is sample. This one is sample. So let's say you want to extract the data for the birthday, right? So if I were to say print I, right, and I also know that it's only up to 8, 2, 4, 6, 8. All right, so print I and sample. Hmm. Print I. No, I'm not gonna give it sample. I'm just gonna make it repeat 8 times. So, how do I say this? Repeat 8 times. Let's see. Hmm. Let's have another variable here. This will be b-day, birthday. This will be a blank string. Okay, so let's put it one by one to the blank string by concatenating, right? So, sample. How do we say stop at 8? we need to have some sort of, let's see. So we know that there's an underscore, right? Let's just assume that the data that we get is in this format. It will always be in this format. So as long as if I is not equal to underscore, right? We can proceed. What's this? Oh, it's just Grammarly. Um, as long as it's not underscore, we know that it's still in the number side, right? So I'm gonna say bday is equals to bday plus I. That would keep on concatenating it until, until we encountered the underscore. So the moment we encountered the underscore, we are gonna what? We're gonna stop there. We can say a break, and then let's print out the bday if it's correct outside. Yeah, I think this will work. Yes. So this code extracts the birthday part of this specific sample of data. Okay. So this is just one of the tasks that you will do when you get your data set. Okay, retrieving information that you need for certain parts. But it won't actually be this weird. Okay, usually they just put the date in some other things. But sometimes we'll encounter something like this. Others they use a CSV format, like separated by um, comma, separated columns, values. So that's CSV. Um, so yeah, that's one example of it. Okay, so that's for the for loop. Did I forget something else here other than the range? Okay, do you guys understand what's happening here? Um, just to make sure. Okay, what's this? Oh, the stuff. How to end the time lapse in IPY kernel. The time lapse? You mean this one? Oh yeah, you can just press the stop. Or if it does not work, you can press kernel and then restart kernel. That will also work. Yeah. Oh, yeah. Before the break, is this example like clear? How we were able to arrive to this output? So we were just extracting the birthday. So I'm using multiple things that we have learned so far to get that kind of output. Yes, Anna, you had a question. I saw you typing.
No, sir. I'm just going to say that I understand on my side.
Okay, okay. Thank you. All right. I'm gonna assume that the others are okay with it. Okay. That this is understood. Why I use this one. What's happening here, and also the break. Okay. Um, so we only move a little bit, but yeah, we can go a bit faster after function because these are just other data types that we're going to use, data structures. So it's fairly simple to use. All right, the last one will be functions, maybe about 20 minutes into that, and then this one. Okay, let's have a quick break. It's 3:10 on my clock. I'll see you guys at 3:30, the same as before. Okay, 20-minute break. Yeah. Don't leave the room. I'll just pause my camera and my mic. All right. See you in 20. Okay, I hope everyone is here. Let's see. All right. Thank you for the confirmation, Rika, Anna. All right. I hope you guys had a good break, process everything, and yeah, internalize. Ryan, thank you, and Vivian. All right. Now let's proceed to functions. How do we define and call functions? So we already know how to call functions, right? We've been doing that one a lot, right? Like print, input, and then we have the int function, we have the range function. I think those were the functions that we have used so far, right? Print, input, int, uh, what else? Print, range. Yeah, we have the range function as well. Yeah, I think that's it. But there are plenty more functions in Python that you can explore. Okay. Let's see. Okay. Now we have uh, an example here on how to create a function. Okay, so we have um, let's see, we have a greet function here. This is how you define a function or create a function, by the way. You start with a def keyword, and then followed by the name of the function, and then open and close parentheses, and then the parameters that you want for that function. Okay. Um, if you remember, the parameters are what can alter how the output will appear, right? And they are also the placeholders for the arguments that you are gonna pass to the function when you are calling them. So here, parameter 2 is a uh, key value pair. It has the key and the value here. It has the default value of Adam. Parameter 1 is a positional parameter. That means it must be uh, the first one. It must be declared at the beginning. So this is the information received by the function. This is a doc string. So as you can see here, there's three quotes. So we call this one a doc string, but it's still a string, really. This will greet the user with hello and predefined name. This is what will appear if you were to um, take a look at what the function um, description is using Python. You can actually do that here also. Let's say, for example, the print. So you can just say help and then put inside here the print function without the open and close parentheses. Just put the name of the function and then run it. Okay. And it says here, it's exactly the same, almost exactly the same as what we have found on the other sites, right? Let's see. So as you can see, the description is relatively the same. So what I'm trying to say is that this whole thing here is what is placed here in the doc string, right? So whenever you're creating functions, this will help further the users that will try to use your functions, right? And then finally, this is nested code here. You can do anything that you want really with your parameters. So since the name of the function is greet, so it will basically just greet the um, user. Okay, so in this case, argument 1 is Daniel, argument 2 is Torvald. I am passing those two here as variables instead of values here, and then it's just gonna say hello Daniel Torvald. That's what it will say in the output. Return statements. So remember the return example last week that I gave you about the waiter? This is what it would look like inside. So it's just really a return keyword and the value that it will bring back to where the function was called. So in this case, it's returning the string done. It's not really returning something that changes with the parameter, right, or the argument that you are passing. But usually it's dynamic. So let's say the input, right, it returns whatever you input as a string. So you can, instead of returning done, you can say return a certain variable, whatever is inside of that variable. Okay. You can also return any data type that you want. It can be a number, a boolean, a string. It doesn't really matter. You are returning it to where the function was called. Okay. So now we have an argument here, Daniel. Greet Daniel, right? We're passing that one here. It's gonna be printed out, and then it will return done. So it will return here in this location the string done, and it's gonna be assigned to the ret variable. And if I were to print that one, it would print done. All right. Now most of the things there we have already discussed before. Okay, so let's try and create our own function and see the difference. All right. A function. Let's create a simple function for now. How about um, uh, what would be a good function? Sum of two numbers. Just a very basic function. So let's say def and then sum. Sum is not a reserved keyword, so that's good. Let's see. So sum of two numbers, right? So we need a placeholder for those two numbers. So where do we put them? Let's say num1 and num2. Okay. So those are my two parameters, right? Now I don't want to declare right now how to say this default values for these parameters, but I do need num1 and num2 to be present, so they are required, they're not optional. Okay. All right, after that, what do we need? We do the process, the operation itself. So we say let's see, total would be equal to num1 plus num2. All right. So now we have total. We can then send the total back to the caller of the function. So we can say return total. Right? And that's it. So we can also add a doc string here. Let's say adds two numbers and returns it. Alright, apologies, my cup is so annoying. Alright, okay, return total. Alright, we can try this one out. You can see this one right now in help because it exists. The sum exists. So if I were to run this, you can see that it looks like that, right? So it will show you the parameters and also the description of it, exactly like this one. See? So this actually helps a lot. Other than the comment, you can also add a comment here before if you want, but there's a doc string for it, so it seems kind of redundant, but you know, yeah. You can put it if you want to. All right, so now it's time to use the sum. Let's say sum of 2 and 5. What would be the answer? It would be 7. Now it's currently output as 7, but it's just there. We're not really doing anything, so we can, since it's returned as the total of the two numbers, we can actually save this one into a variable. So let's say What's this? Sum. This is the sum of what? Coins, for example. Sum of coins. And then we can print this out as I have coins. Left. What is this? Oh, okay. So I forgot. This is a number, right? I have to convert this one back to string. So it just turns out that we have an str function that converts things to string. It works exactly the same way as the int. You pass in anything there and it is converted into a string. Exactly the opposite of how the int works. Okay, so now we have created a function. We have used a function. So I hope by this time it's making much more sense, right? How the 2 and 5 is being used inside of the function. Okay, so now you kind of get why I said before that num1 and num2 are kind of like the bowl, right? You have a name on the bowl, but there's nothing inside of it, right? But you know exactly what to do once you have something inside of those bowls. You're gonna add them together and then you're gonna return the total, right? So this is exactly what I mean. These are the arguments. These are the actual values that you put here inside of your bowls, your parameters. Okay. We can even make this more efficient, right? Here we are having a dedicated variable for num1 and num2. And as you can see, after this, we are just using it to return the total. So it's actually redundant, right? We can just remove that totally and then just put the return statement here. It would still work the same way. See? Sir, can we have multiple return statements? Yes, you can even have something like um, you can even do it like this, like if we have to put back the total again to make it work. All right, so if if total is greater than 5, then I want you to return the value of total. Otherwise, else, I want you to return the value of 5. So this makes sure that the minimum number that will be returned will be 5. It will never be lower than 5, right? So if I have to run this one, wait. Oh yeah, so it's not dynamic, so it's 7, right? If I were to change this one to like 1 and 3, I have 5 left, so it will always give out 5 as the minimum, right? So you can have multiple return statements. The difference is that once a return is encountered, it will exit out of the loop and then goes back directly to the last line that it was called, which is here. Okay, and then return whatever is returned to this location and so on and so forth. Okay, so I hope you guys understand now how a function works. The function cycle works from beginning to end, when it is called and when it is defined. Okay, yeah, remember you can assign default values if you want. What else? A function, yeah, you can mix and match those things, by the way. Okay, so you can put a function inside an if, right? You can put a loop inside an if, or you can put an if inside a loop, or an if inside a function. You can mix and match these things as long as it makes sense. Okay, so you can create a loop where it calls a certain function, right? So why would you do that? Because it makes the loop easier to understand rather than putting the whole code there inside of the loop, right? If the code exists somewhere already, right? Um, there's really no reason for us to rewrite it again. If it exists already, put it into a function or create a function of it and then just use that code, reuse it, right? Um, Yeah, but if it's okay if you forgot that part when you're still working with the code, like I said, make it work first before tailoring it. Okay. What next? So I think that's all for the function, really. Yeah. Let's go now directly to our next data structure. So for now, for a while, we have been with just numbers, the int and the float, right? Strings and booleans. Now we have a new one, and it is called a list. All right. So this is technically, right, a new data type. Wait, no wait. How should I say this? This is I think data structure is the closest word. Yeah, this is a data structure. Okay. Um, it stores a series of items or data in a particular order and can be accessed via index numbers. All right. Here are some examples that we have. Characters. This is how you denote a list, by the way. The syntax is an open and close bracket. Okay. Each item inside is separated by a comma. So Zelda, comma Goku, comma Thor, and so on. And this is for the number. All right. One rule that is followed for lists is that if you have one data type, make sure all the other items, okay, each value that you see inside is called an item, is also of the same data type. Okay. Um, yeah. So if it's float, make sure everything is a float. If it's a string, make sure everything is a string. Sir, can we mix and match the different data types? Yes, but it doesn't really make sense if you do that for lists because you're accessing them one by one, right? So the assumption is they will have different, the same data types. Otherwise, if they have different data types, it would be a bit harder to process and the data structure itself won't make sense, right? Especially if you're mixing strings and numbers. Okay. The example below here is an example of how to get different items inside of this data structure, the list. All right. You indicate it, you get it using the index um, index numbers. Okay, these are called the index numbers. So how do we know what the index numbers are? So in programming, right? Um, Especially data structures, okay, like lists and dictionaries, they almost always start at zero. Okay, they almost always start at zero. I haven't encountered anything, any index number that started with one. It should always start with zero. I think that's just how computers work. So in this case, Zelda is at index number 0, Goku is 1, Thor is 2, Constantine is 3, Batman is 4. Okay, so If I were to say characters 0, it would access Zelda. Okay? If I were to say characters -1, it would answer Batman. So it's just counting backwards. Okay, and that's how it reached to Batman. Okay. The same thing goes even if there are numbers. The items inside. All right. Um, what else? The list is also an iterable object. So that means you can use this one directly in a for loop. So let's go ahead here. Let's create a simple list. How about places? All right. So I'm gonna say Phil for Philippines, U.S., Korea. What else? What other neighbors do we have here? Japan, and then Singapore. All right. I think I'll stop there. Okay. So this is our list. Philippines, Korea, US, Japan, and Singapore. If we were to put this one into a for loop, right? For I, it does not need to be I. Okay, guys. You can have any name for this placeholder here. All right. It's just that I is very common since the dawn of time in programming. They have been using I as the value for the current iteration. So yeah, for I in places, so if I were to do that, what will it do? So when computer encounters that code, it will read it as, hey, places, give I your first item on your list, which is Phil. Okay, so it's yeah, it's read from left to right. So if I were to print this one, right, and then say places here, run the code, and it repeats 5 times. Let's see, why was it repeating 5 times? So, oh yeah, I was supposed to put I here. There we go. So it repeated 5 times because there are 5 items on this list. Alright, and when it reaches the end of that list, it will stop by itself. Okay. We have here 4 I in places, so each of those locations we pass to I, and then print I, and then it will just print out the location of the country. All right. What else am I missing? Okay. For manually accessing it, you can say places and then 0. That would give you fill. This one would be 4. 4, right? So it's 0, 1, 2, 3, 4. What else? We can try work around with the range here. Like there's a function called len. It's a len function. So the len function counts how many items there are on a list, right? So if I were to say len places, it will give me 5, which is correct. So 1, 2, 3, 4, 5. This will make it more dynamic if rather than just putting the actual object there, right? So if I were to say len places, it will give us back 5. Okay. So now that we have 5, what can we do? We can let's see. We can put that in a range function. So how does that work? We know that the len counts how many items there are, right? And the range function, we know that the stop parameter is where it will stop, but it will not end. Um, it will not end at that uh, location. So if I were to say, so 1, 2, 3, 4, 5, for I in range of len of places, right? Range in len of places. Okay, so it's gonna start at 0. This would give us what? This would give us 0 to 4, am I correct? 0 to 4, yes. So that means if I were to put here as an S, right? Print places I. I hope this makes sense. So I'm accessing the places list, right? And instead of the actual index number being placed there, I am using the I as a way for the number to change by itself, right? So in this way, the code is a bit more dynamic, right? So if I were to run this code, it will give out the same sort of answer that you have here. Okay, so I'm just showing you guys how the ladder works in this case. Let's see. Looping in the list. So card and characters. So here are some shortcuts. When you want to slice a list, you can have, let's see. Alright, so what is this code giving us now? It's only us giving Philippine and US, right? Because we put here places is wait. Let's see. Okay, I think I forgot something here. Anyway, so okay, I think I'll get back to the thing. But what I wanted to iterate on this was that in this for loop, we are accessing the items themselves, place them to I. All right. In this for loop, we are accessing the items of places via index number. Okay, so there's a difference. Is that difference important? Yes, because sometimes you actually need the index number more than uh, the actual value themselves. So it depends on the problem that you have. Sometimes there are problems that involve locating where a certain item is rather than the value. So if you're locating the item, you have to know the index number. So the one that I was trying to figure out here earlier was that if I was to locate um, Korea, for example, if places I is equals to Korea, right? What would happen is that um, I would mm, let's put it to a variable here. Let's say we are looking for location. So location is still a number 0, a black one. We'll put a 0 for now. Then we'll change the lock to whatever I is, and then we break out of the loop. So in this case, for example, we're looking for Korea. Where is Korea located on the list? Then it will give out. It will give out location. Oh yeah, print. Uh, it's located in index. Plus, anyway, lock. Not it. I is what? Okay. String. Okay, it's located in index 2. So this is what I mean when There are instances where I'm actually looking for where it's located on the data structure itself, on the list. All right. Um, you can slice a list if you want using the index numbers. You just have to put a colon at the beginning. So this actually indicates the from the beginning up until 2. The first 2 up until index 2 without including 2. This is what it means. So if I were to say um, places, right? If I were to say places and then colon 2, in this example, it would give us fill and US. Places. It would give us fill and US. So it's 0, 1, and 2. Whenever you're using this is a stop sign. Stops at 2, and then um, does not include 2. So that's why we only have fill and US here in this example. Okay. Um, the other one works also if you want to start at index 2, right? And then you want to go all the way to the end. Just leave the other one blank. You do that, you get Korea, Japan, and Singapore. Okay. If you were to indicate, right, it would be where's it? Places. It would be fail and yes. Wait, 2 3 0 1 Korean and Japan. Korea. Oh yeah, I forgot. The third one is not included. So what else? I think that's all there is. Copying a list is just as simple as doing it like this. Um, why do you need to copy a list? So, in programming, one rule that you should also follow is that when defining functions, right, or creating functions, what you want to do is you should be able to get the data, use the data, but you don't modify the original, right? You do not modify the original so that you can refer to it back later when you need it. So that's one of the reasons why we need to copy a list. Okay? Okay. I think that's really it for lists. There's nothing much to discuss here. Maybe there's uh let's see. Objects and methods. Okay, that's the last one. Right, that's for list. Tuples, similar to list but items in the cabinet, cannot be modified. This is ordered and unchangeable. So this is like, it does not really prevent you if you really wanted to change the value. You can want, but most likely the tuples here are just used to um, give your ticket or not ticket, give your uh, anyway, let's just treat this one the same as a list. But the values cannot be changed. If you do, it will give you an error. And then this is the syntax, right? Just use open and close curly brace, open and close parentheses, and that will be your tuple. Okay. Their main difference with the list is that a list has a lot of properties and methods, while the tuple has lesser, I think, because you can't really do much with um, tuples, right? Any questions so far? Okay, none. Okay, so that's for a list. An example for a list. We had it already. Mhm. A pen. Yeah, let's discuss this one later when we get to the method. Tuples. Dictionaries. Okay, so a dictionary is another type of data structure. By the way, whenever I say data structure, it's just a way of storing data into something more rigid, like a variable. So you put all of those things inside that variable. Okay. Now, dictionaries here stores connections between pieces of information. Each item is a key value pair. No duplicate keys. All right. Okay. So this is the syntax for how to create a dictionary. You have name equal and open and close sign of curly brace, right? And inside are the key value pairs. All the ones on the left are keys. All the ones on the right are values. Okay. Sir, what is your advice for creating dictionaries? Should the keys always be string? Yes, because you can treat them like some kind of variable, really, to it even acts like that. And then on the other side is um, on the other side are the values themselves. Okay, let's see. So over here, this is more practical to have different data types in every variable. It makes sense because when you're um, let's see, when you are taking notes of something, for example, and then it involves multiple things other than words or strings, you're gonna need a way to input those numbers eventually. So now you can put them automatically in uh, in their respective location. Okay. Let's see. All right. So our dictionary is fairly simple. Name, colon. Key value pairs are always separated by a colon. Let's see. Mhm. All right. So if you want to access a value in a dictionary, earlier for a list, what were we using? We were using index numbers, right? In here, you can actually just use the name immediately, like this one. So use your name. So we're gonna go and let's see. Next one would be if you want to add a new, right? A new key value pair, you have to just you can directly enter here, put a comma, and then enter, and then add directly the value here, or you can do it into something like this. So user is referring to your um, dictionary, and then you put address and then equals this, and it'll allow you to drop it there. Let's see. Alright, set similar to list, but the items in a set cannot be modified, only add or removed. It is unordered, unchangeable, and no duplicates. Basically, you just want a set if you want to make sure that there's no double in your um, data structure, right? So in here, we have these years, 23, 5, 15, and 2022. Okay, so it will automatically delete all those uh, all those numbers, and then yeah, if there are multiple copies, it will just be removed. So ideally, I don't really use a lot of tuples and sets. Most usually, I just use list and dictionaries, because those two actually came from dictionaries. All right. Let's see what else. I think that's pretty much it. Oh yeah. So for data structures, you can combine them if you want. Let's say you have a dictionary. Sample is equals to curly brace, right? Like this one, Python understands that this is one statement. The moment that the other side is reached, that is one statement. Okay. Let's say for example here the places. We can actually put this one here and change this one to colon Senegal. And comma. Should make this into a string as well. Alright, what else? How about places? How about movies? These are good. So we have audacious. I'm not sure with the spelling. Mm-hmm. I can't even think of now that I'm thinking of them. Mhm. Alright, so how do we access this one using index? So let's say sample. I'm gonna call places. Right? Wait. I want to add another one here. Alright, so this is the part where you have to be careful. Let's say you're trying to get Japan, okay? How do you get to Japan? So first you have to explore the places key value pair, right? So places, that. So we are accessing the dictionary at this point. Now, if you remember, we're also using the same uh, things, right? And you have to take note of the data type. So in this case, places here at this moment when we try to retrieve like, let's see, how about Japan? Let's try Japan. So that is index. Wait. Index 0, 1, 2, 3. Okay. So as you can see, I just change them up like this. You can actually change them up request like this because, or code like this one, because at this point, um, it was still like here at this point, right? And then over here is where it's looking for the number 3 index, which is Japan, right? Okay. Yeah, I think that's good for list and dictionaries. I can't really think of anything else at the moment. Again, sets and tuples, I don't really use them a lot. Sets, if you want to remove duplicates, but usually list and dictionaries are enough. You can put dictionaries in list, you can put list in dictionaries, and vice versa. Um, right, let's go to objects, methods, and properties. So finally, the part where we need to understand what objects are. All right. So an object, right? When you look at an object in real life, let's say for example this mug. Yeah. So when I am looking at the mug, I need to describe it, right? So the mug is hard. The mug is white. It says design. Um, it has flowers on it, right? So I'm explaining what the mug is. Okay, now if we were to convert that analogy into computer terms, right? Um, the string is an object, right? How would you describe the string, right? You can describe it by the size of the string. So, um, the longer the word, the heavier the size, right? In terms of bytes. Um, so that can be one of the properties, the size. Next is where it's located in the RAM or in the hard drive. That is also a property. Um, what is the actual value of the string? That is also a property. There are tons of other values or descriptions that you can say in order to describe the string. Okay. What about methods? Okay, so methods are the things that it can do, right? Now, why does it sound familiar? Because it sounds familiar because that's what functions are, right? The main difference between a function and a method is that the method acts only on the object itself. All right. Now, if we go back to the mug, what are the methods of the mug? It allows me to hold hot things and cold things. Um, what else? It mm, can't really think of other things that this can do. It can resist breaking if it falls. Is that something? I'm not really sure, but I hope you get the picture what methods are. So methods are the things that the object can do, right? In fact, our analogy here in our example is that if the car is our object, then the things it can do is accelerate, brake, turn, uh, air condition, and the properties are the one that describing it. So the color, the make, the model, material. If you combine that two, it will be the complete description of the object itself to exist, right? Now, how do I prove that? So in Python, right, we have something called the properties and methods, but how do we know? Like, can we see that one? We actually can. So we use the dir, and then you pass in a certain um, a certain object. So let's say the places object that we created earlier, and then I run that one. This is what you will see. Okay. Now, um, earlier I told you that we have size. So as you can see, size is one of those, right? So the size of the places variable, which is this one, right? The 5 locations here. Let's try and see. So there are places, looks like um, this. So we need to access this one, right? So how do we access a property? So we say places. Let's see. Places dot size of enter. Okay, so it says function list size of. So it's actually a size. The size of property is also a function, but the function is not really doing anything to the object. It's more like it's using the function as a way for us to get the value. So you have to trigger it, and we can see that the places variable has the size of 88 bytes. So if I were to run the dir again, this is what programmers do usually when creating properties. They denote an underscore at the beginning and at the end. Okay, take note, not all do this. Okay, some have a different way of showing what properties are. So if you're mixing and matching different technologies, right, it's gonna get confusing, especially if they don't follow the same convention like this one. So I'm not really sure what the other properties are, but I'm sure that it describes the list called places. Okay, now let's go to the um, methods, right? Now the methods are actually functions, so you can just use them directly like this. Okay, so places dot uh, let's say count. Let's say count dot count and open and close parentheses. Places dot count. Takes exactly one argument. What argument? So I'm not really sure what that is. If I were to say help, right? So you always. So remember when you're using help, you don't have to include the open and close parentheses. Run it. Okay, so count value method of built-in list is return the number of occurrences of value. Count. Return number of occurrences of value. Alright. So I think I know how the count works. It counts how many times a certain value has repeated. So if I were to put 2 US here, and then I say count the number of US, it will say 1. What? As it told us 2. It should be 2. Or am I using this wrong? Okay. Let's see. Why did it say 2? Oh, 1. 0 and 1. It's located here. Let's see. By the way, we're using dot because the way to access properties and methods is called the dot notation. And this is also how it works in other languages. So yeah, but the difference is that in Python, yeah, especially the built-in ones, they have their properties as functions as well. Other texts have it like as is. Um, if you just put the name directly without using it as a function, you will see the value directly. Here, they have it as a function first. Now, we're looking for properties and methods, right? That means whenever you're scanning resources like this one, you can go directly to what? we're having a list, right? List methods here, list methods, and the count is here. Count the number of elements with the specified value. Count cherry. 0.9. I did say US, right?
Sir,
Yes.
have you run your script dun sa inad niyo po yung US?
Yes, correct. Thank you for that. I forgot to run this script. Very good, very good. So that's why it was saying 1. Thank you for that. Okay, now it says 2. Okay. Yeah. So yeah. Right. What else? So by the way, the syntax looks like this. Don't get confused when they say list.count. Usually what they put here is the data structure or the data type that they are using, especially in other texts. Like for example, later on we're gonna be using pandas, right? And they have something they call a data frame, uh, something that they made on their own, kind of like their own data structure. So they're gonna say these are the data frame methods. So they're gonna say data frame dot something something or uh, whatever methods that they have. So it's kind of confusing at first, but basically you don't have to say list dot count. It's referring to the list that you have. It's a placeholder. So list here is what places here, that we have here in our notebook, right? So it's kind of confusing at first when you see something like this in the references. Um, yeah, I think that's it for objects, methods, and properties. Yeah. So why are we gonna be using methods, right? So methods will um, work only on the object that it belongs to. So count here will just count US on this object, on this list, right? If you have another list somewhere, and then that list also has US there, it will not include that in the counting, right? It will only count on this object. It will only act on that specific object that it belongs to. Okay, that is what makes methods different from functions. Okay, um, so yeah. What else? Do you have to memorize all the methods? No. More like what you're gonna do is what think about what you're working on. So if you say, I'm currently working on a list, right? And then you say, what are the what are the different things the list can do? So you just go directly to list methods and then, oh, I can actually copy this one. I can actually extend, insert. Oh, I can even sort it out if I wanted to, right? If the function, right, already exists, make use of that one before you actually consume a lot of time and create one on your own. Okay, so make sure to explore them. You don't have to memorize them, but like just read. This is actually enough for me. Whenever I'm working on something new, I just read the different methods available, and then their description, because at least I will have it at the back of my head that, hey, I think I remember there's a method for this available for this specific data type or data structure, so I can just go ahead and look it up for a few minutes before I actually spend 2 to 3 hours making my own function for that same thing, right? So yeah, it happens, but um, yeah, if it exists, just make use of that. What else have I forgot? I think that's it, really. Let's see. Oh yeah, a way to print a lot easier, but it's not really that useful in data science. You can print out using the F string, so F like this, and then you can combine different um, different data types and print it out as one. So you can say like um, hello, and then you're gonna call places, and then index 1, for example, right? And then this one, enter. So hello US, right? So this is called an F string. You put quotes around everything, and then you type your string as is, how it's formatted, and then if you want to include variables, you can put it inside an open and close curly bracket like this one, and anything inside there is valid code, whether that code is a function, is an expression, or a statement. It's a valid code. So you can put it inside there. It will be processed first by Python before going outside and processing this one. Okay. And aside from that, there are some minor things that we haven't discussed, but it's not really that um, important. You can actually look them up on your own as you find them in your projects while you're creating your projects, right? Let's see. Most of the things that are very critical we have discussed. So, yeah. Arrays, iterators, yeah, not really. Regex, no. Pip, no. Classes, I don't really have that much um, experience creating classes for data science. Mostly just functions. Classes, not so much. Let's see. So all the other things here, you can read them on your own. But the things that we have discussed, these are the critical things that you will need for data science. All right, so let's have one exercise that we can try to see if um, we can you know put everything that we know and see if we can make it work into this exercise. Let's pick a hard one since it's about time. Create a list of countries and loop for each item and print welcome. Create an inventory for a simple store using a dictionary where the keys, price. This will actually take quite a while. Transform the list of number 1 to uppercase. Okay, it's related to 1 and 2. So, yeah, okay. I think this one will do. The number 1. Alright. So, one exercise only for today. Create a list of countries, same as what I did earlier, and loop over each item and print welcome to whatever that country is. So modify the output. If the starting letter of the country is a vowel, transform the entire word into an uppercase and lowercase if not. All right. So yeah, you get to do your own research on this. So what would you guys do, right? So this is your problem. Okay, so you're gonna be dealing with loops. You're gonna be dealing with conditions. You're gonna be dealing with strings and methods. All right. Okay, so I think 10 minutes should be enough for this, or 15. I'll give you guys that, and then we'll check your work. Okay. So this should compose all the things that we know so far. I think I'll just make this one into an assignment for you guys. Yeah, I think it's better if I were to make this one into an assignment. So yeah, scratch that. Um, if I'll upload this one as soon as I can, and then yeah, create solutions for exercises 1, 2, 3, and 4, and we'll check your work next week. Check your work next week, or I wonder if you can send them here on Discord. I think you can send it here on Discord. Drop it by on the chat or somewhere, and then I'll check your work, and then I'll choose from one of you guys, and I'll present it to the class next week. All right. So we'll use that one. Um, One last thing. Uh, I remember last week I told you guys to think of some topics, right? So for now, the next step for your project would be, uh, since you have topics, I want you to look for sources of your data for your chosen subject. So it may come as an Excel file, a PDF, or a CSV. Okay, sometimes it can also be from a database or an API. Um, if there's a guide, usually it's not. It's really simple to get data from these things. But if you don't know how to use them yet, that's okay. Save the sources and we can explore them as we go along with the lessons. The more sources you have, the better. If you don't have a topic, at least look for any kind of data set that you can get, right? And then we'll play with that data set. Okay. Um, that's it. Okay. So, any questions so far before we end? Okay.
Me, sir.
Okay. Yeah.
Um, ah, kasi 'di ba sir may AI na.
Mm, mm.
Gaano po kalimit yung paggamit namin ng AI
It's okay to use
para
AI for the full like solving the exercises and that stuff. Yeah, it's completely okay. The only problem with AI for me is that at least maybe try 15 minutes, 30 minutes, right? That you actually try to think, critical thinking. That's the most important part. After that, you can use AI to guide you along on how to solve the question. That's completely fine, actually. If you were to like um, spend an hour or 2 hours trying to force yourself to solve an exercise, I think it's not really productive. It's more productive to know the answer and then learn from it, right? But at least you tried it first. The important part there is that you are uh, training your muscle, your critical thinking, right? That's the most important part. Or if you can't actually generate the code, at least you can generate the flow. Like you can say to yourself, like, okay, I was in the right train of thought. I have the correct idea. I just did not know the syntax yet. I did not know how to put the code. But if you know the sequence of it, that's good enough. Okay? And then if you can get the code from AI, that's perfectly fine as well. Right? The AI is supposed to be our assistant. So make it work for you, not against you. Alright?
okey po sir. Sir last na sir,
Yes
puwede
po.
pa-screenshot lang po nung papunta po dun sa 17 po yata yun? Para ma-screenshot ko lang po.
17. Okay. Yeah. Here you go. I'm also gonna
Thank
upload this one.
sige po. Thank you
Yes.
po.
Yes. Let me know when you're done.
I'm okay na po sir.
Okay na.
Thank you.
All right. So, yeah. How about the others? Is everyone still okay, or is it too much information for one day? Ryan, Vivian, Rika, all good. Okay. I've had some students before that stopped at around 5 sessions, I think, because yeah, there was simply too much information. Good for me too, but still working on the exercise. Yeah, yeah. So please work on the exercises. Submit it here in Discord. Um, you can send it to me with screenshots or maybe a notepad, and then I'll write it here on my end. Um, yeah. So any method that you can think of to send it to me, that's perfectly fine. All right, so that's it for this week. I hope you learned a lot. I'll see you again next week. Have a great weekend. Thank you, guys.
Thank you po.